So we spent some time foiling last lesson, now factorizing. We are still just recapping from the grade 9. Guys, you got to get it right 100%. It needs to be really ingrained in your brain, because already in 2 lessons time we're going to get into something which is new and it's quite difficult. So you really need to get these things right. When you check your when you do your homework, okay, your classwork, whatever you want to call it, okay, you got to check the answers. There are answers at the back of the textbook, and you need to check you got it right. Okay, very, very important. Okay, so factorizing is basically working backward. If last lesson we had things like a plus b squared equal a squared plus 2ab plus b squared, that was foiling. If I'm going backward to something times something, that's factorizing. This way is simplifying or foiling. This way is factorizing. Why do we learn to factorize? Good question. We'll try and figure out later. Okay, it doesn't help us though. So there's a couple of strategy, couple of techniques, things we can do to factorize. So we've got 12x cubed minus 18x squared. In this case, what you need to find is a common factor. Okay, the highest common factor. So I'm looking at the number. Let's look at the x's first of all. X cubed and x squared. X cubed is x times x times x. X squared is x times x. Okay. So the lowest common, or the highest common factor will be x squared. Okay? In terms of the number 12 and 18, the highest common factor will be 6, I think. Okay? Yeah. So I get out 6x squared, and then I open brackets, and then I need to have something here, which if I times by 6x squared, I'll get 12x cubed. And that something will be 2x. And then minus, what do I need to multiply 6x squared to get 18x squared? Simply multiplied by 3. So that's the answer. Now when I must look at it and see, can I factorize anything else in the brackets? And the answer is no. There's nothing there. Now, let's have a look at this. I've got x, a plus b plus y, a plus b. Now, you might be tempted to start opening it, but no, we actually want to work backward. We want to get into something times something. So in this case, the highest or the common factor is a plus b. You can see it's there and it's here. So then we're going to add open brackets, and we're going to say, okay, x plus y. Okay, because x times a plus b is that, plus y times a plus b. Okay, and that's fully factorized. Now here, I've got a similar situation, except that here I have q plus r, and here I have r plus q. Now, is that going to be a problem? No, because q plus r equal r plus q. Like 7 plus 5 equal 5 plus 7. It doesn't matter. So I can swap them around. I can say the common factor is q plus r, and the first bit will be 3p, and then the second bit, because I've got a minus here, is minus 4n. Okay? Remember, I must always check, see, can I take any factor here? No, there's no common factor. Okay, things a little bit more tricky here. What's the highest common factor? Okay, it's going to be a plus c to the power of 4, because a plus c to the power of 5, a plus c times a plus c times a plus c times a plus c, blah, 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 4 times, and then times a plus c. So the tricky bit here is to figure out what's inside the other brackets. What should I multiply a plus c by? A plus c power 4 to get a plus c power 4. So the answer is I don't need to multiply it by anything. But if I have to multiply by something, then I won't multiply it by 0. I'll multiply it by 1. Okay? Plus. Okay. What should I have now here? What must I multiply a plus c power 4 to get a plus c power 5? Well, the answer is a plus c. So this is the answer. 1 plus a plus c in the brackets. Okay. Right, this is another one that hopefully you remember. We've got n minus 3n, 3n minus n. So again, we swap the order, but now instead of having a plus like we had here, now we've got a minus. Now, I know that, I'll write it down, 2 plus 3 is equal to 3 plus 2. That we can swap them around. But is it right that 2 minus 3 equals 3 minus 2? Of course not. 2 minus 3 is minus 1. 3 minus 2 is 1. So there's a change in sign. Okay? So what I got to do, if I want to swap the sign, it's okay. I'll write it down. So I'll write 7x n minus 3n Okay, now I want to write the other one, the 4y time, I want to turn it to be the same. So I'm going to write n minus 3n. And I can do it, but I must pay a price. And the price is to change the sign. So if this was plus, now it's going to be minus. Okay? So by swapping, 2 minus 3 is the same as 3 minus 2, but I need to put a minus sign here. If it was already a minus, then it will turn to a plus. And then from here, I think it's quite clear. n minus 3n is a common factor. And then I have 7x minus 4y. Okay? So swapping. When I have to swap when there's a minus, I have to change the sign. All stuff that we done last year. We're moving on to what we often call dots. Difference of two squares. Okay? So x squared minus 36 squared. Okay, we can write it as x squared minus 6 squared, right? Because 36 is 6 squared. So we've got a difference, there's a minus, and we have two squares, two perfect squares. And the formula we learned last lesson, if you remember, a plus b times a minus b is a squared minus b squared. So as I told you, that was working this way. Now, in factorizing, we're working backward. So now I've got an a squared minus b squared. Therefore, I should be able to write the a plus b times a minus b. In this case, the a is x and the b is 6. So that's going to be x plus 6 times x minus 6. Okay? Right. Now here there's a couple of things we need to do. First of all, okay, I can do a difference of the square, but personally what I would do is, first of all, always see if you can get out a common factor. So before you try and do a difference of square, see if there's a common factor, like there is. And there is a common factor. Common factor is x squared. So what must I multiply x squared to get x power 4? The answer is x squared. What must I multiply x squared to get x squared? Nothing. In other words, I need to multiply by 1. Now remember, I told you, you must always check your brackets and see if you can factorize it any further. And this bracket I can still factorize, okay? So x squared remains there. What is x squared minus 1? Well, it's x plus 1 times x minus 1. So you see, sometimes you'll have more than 2 terms. Here, okay, 16a squared. It's worthwhile sometime writing. It's a square of something. What is it, a square? It's a square of 4a. If I square 4a, it will be 16a squared. 121, maybe you remember 121 is the square of 11. So I know there's something, there's an 11 hiding there. 11b, all of that must square. Okay? See, that's why sometimes it's worthwhile remember without the calculator. I just remember 11 squared is 121. So I know there's a square hiding there. And then I'm going to use this formula to write it as 4a plus 11b times 4a minus 11b. Okay. Similar thing, but another letter. So, as I told you already here, it's worthwhile, first of all, to get any common factor. So, I've got a 27 and a 3. So, I know a 3 is a common factor. And also, I've got an a in both of them. So, I'm going to take 3a. Because as you look at this like now, it doesn't look like a difference of a square. But if I take out the common factor, the 3a, I'm going to get 9a squared, right? 9a squared times 3a is 27a cubed. Minus b squared, and now you can see the difference of the square. Okay, first of all, I'll write down 3a because I mustn't lose it. 9a squared is the square of 3a, so I'm going to have 3a plus b times 3a minus b. I'm just going to see if you can see it. You can see the edge? Yeah, you can see it. Fantastic. Okay, I'm going to rewrite this one again because we'll need a bit more space for that. Alright, what do we have here? Actually, that's really easy. It's in front of me. I can see that it's the square of this minus square of that. It's the difference of a square. Only the first one, the a, is a plus b. So on the right is a plus b plus c times a plus b minus c. Okay? Can you see this is very similar? I know we did it in the last lesson. It's in the last one. So we had something like this, we turned to that. Now we're working the other way. Alright, hopefully that was clear enough. Good luck with the exercise.